Good day, students, and welcome to today's lecture. Today we are going to be speaking about week 5, teaching and learning theoretical content within information technology. So previously, in our previous weeks, we spoke about setting up the computer lab and so on and so forth. We are now moving on to a new content, and we shall be speaking about covering aspects that are theoretical within the classroom. So some of the topics that we will go over are some of the teaching strategies that you can use. And specifically, there are 3 types that we will be looking at. And those are your direct instruction, problem-based learning, and your cooperative learning as well. So today's lecture or talk will be covering direct instruction and your problem-based learning as well. Okay. The other thing that we will cover in your next lecture will be cooperative learning and also some of the pitfalls that you may experience in teaching theoretical content. Okay, so within information technology, uh, this is a field where you can expect it to be ever expanding. Okay, so what this means is there's continuous changes within the information technology field, and it is your duty as a teacher or an IT person to keep abreast of all these changes and updates uh, within this field. And an example comes to mind, as you can see, the diagram on the screen actually shows you different display ports for your computer. And when I remember back in school when I was taught the theoretical aspects, we didn't have so many ports. It was essentially your VGA port that you see on your screen and your DVI port that you see there as well. However, since then till now, a lot of ports have been created, and there are various ports that we nowadays use, predominantly HDMI. However, it's not uncommon to actually find a computer with a display port or mini VGA, for instance. So coming back to the point of teaching theory, remember this is a field, as we say, it is ever expanding, and you as a teacher will not or cannot just rely on a one-time learning of these, as information is always being updated. Furthermore as well, there are so many people in research who are looking into areas such as different pedagogies and pedagogical methods, and the increase or expansion of information coupled with these researched pedagogical methods creates new ways of teaching and new ways of in within the teaching and learning processes. So it is our duty as teachers to actually look to these alternate forms of instruction and also have a knowledge of the basic forms of instruction as we were taught as well. Okay, so some of the what's the subject matter that comes up when teachers are speaking about teaching theoretical content uh, will be highlighted within the slide. So the first one that I want to speak about there is, remember, when you are teaching theory, not to make learners memorize content. So much of your syllabus you will encounter is solution development, which is about 60% plus or minus, and the rest of it is theoretical aspects. But as a teacher, it shouldn't be a case where we are creating content and we expect students to memorize it in a padded fashion and to regurgitate it in tests and exams. This isn't adding any value to the students' knowledge. Okay, so as a teacher, try and avoid, you know, encouraging students to memorize content. Instead, appeal to them and make them see the value in actually understanding as opposed to memorizing content. Okay, another important aspect to cover within teaching information technology as well is to understand where the difficulties lie within particular topics. So if you are teaching a particular topic and you need to actually get across to students, you as a teacher need to understand which areas are actually problematic for students. So in essence, before you actually cover a lesson, you should be familiar with the areas that may prove difficulty. For instance, if you are teaching networks, to explain to students the difference between a router and a switch, or is it the same thing, or students encountering these things for the first time may not fully understand these topics, and you need to understand that these areas may pose some difficulty for these students. Okay, so that is just one example. Another example that we can, or another topic or aspect that we can speak about is to also know what, understand or evaluate what learners actually know. So this comes back to what we spoke about in your first semester as well. If you recall, uh, when it comes to actually solving programming problems, it is important to know what you know and what you don't know. And as a teacher, when it comes to theory, you will need to decide or evaluate students and ascertain what they actually know before going ahead with the lesson. So you can't really speak about content such as, memory and hard drive space and so on and so forth, when students don't actually know how a computer connects or fits together all the different components. So in that sense, you need to evaluate what they know first before continuing with any material. Okay, so another issue that we can talk about, or aspect that we can talk about as well, is that many students are finding or find content taught in school or in classes for that matter within many different subjects uh, as boring, or they lose or have a short attention span, and they quickly get bored. So it is important that we understand why students are not engaging within the class. Okay, so uh, the other topic that I want to speak about is this, that, and I've actually come across a research article uh, which covers some of the precursors or predictors of boredom at school. So it's not directly dealing with IT, it's more dealing with maths. However, some of the predictors that are spoken about or research are relevant to all subject matter. So we're going to look at that in the next slide. Okay, so this research paper was written by the following authors that you see on your screen, and was published in the British Journal of Educational Psychology. And essentially what they are looking at is uh, it's essentially why students get bored in classrooms. And this is important because if you can understand why they are bored in their classrooms, you can overcome these issues and get more engagement from your students. So let's look at some of the content that's covered in this article. By the way, you can find this article online. It is openly available to you if you want. So this study was conducted in a British environment, and the participants numbered around 1,380 students, and they ranged from grades 5 to 10 specifically within the mathematics subject. So some of the stats that came out from this were, as you can see on your screen, 44.3% of students were partly too strongly in agreement that they frequently experience boredom in their mathematics class. So this is almost half of the class. So this is actually an indictment. If you look at it, if you have researched and surveyed students from grades 5 to 10, and almost half of them have already said they experience boredom, then there are some issues that need to be actually looked at. So the next part that researchers also found out were noticeably strong relationship that was found between boredom due to teacher dislike and boredom due to lack of involvement is logical. Because if we look at this or understand this, okay, let's complete this. On the other hand, students who do not feel they very integrated in the interactions during their mathematics course may dislike their teacher more and thus feel bored in class. And lastly, on the other hand, if students like their teacher, they might participate more actively during class and be less bored. So one of the findings that came out of this research study, which yielded a significant result, was that they found that teachers or students had a particular dislike for certain teachers. And part of the cause or the reason for some of this was due to lack of involvement. So you are a teacher that isn't interacting or integrating content in your class, or interacting properly with the class or engaging. Students may form a dislike for you, and this is understandable, because if you understand that you aren't engaging anybody, how do you expect them to participate in your class? And another part of the study was actually there seems to be students who feel overly challenged by some course material and under challenged by other exercises. This could be due to the diversity of mathematics subject material, since students are confronted with very heterogeneous content and exercises. Okay, so there's two sides to the coin here for this part. Some of the students are feeling like, okay, the work is too easy and they're bored, and other people are like, okay, you know what, this is too hard, I'm not going to manage. However, this isn't the teacher's fault. Perhaps the teacher may have set content that caters for all levels of students in the classroom. So there's two ways to looking at this. So students may have an issue with some aspects of some exercises, but for the most part may be able to cope with this. So the reason for my including this article within this lecture is we are talking about teaching strategies for theory. And one of the aspects that when teaching theory is to overcome boredom. So if you are a teacher who experiences this sort of thing within the classroom, I would advise you to actually look at more studies like this and understand the psychology behind why students are actually feeling bored in your classroom. So this article is very interesting. I've only covered like two of the like 8 issues that they actually speak about in terms of predictors for boredom at school. So you can go ahead and actually look at that and read that on the internet. It's there for your information. Okay, coming back to the main aspect of this talk, which is teaching strategies for theory. Now, teaching strategies for theory, like I said before, there are 3 that we will cover. The first one being direct instruction. So this is the most common that you as a teacher will experience on a day-to-day basis. It's a form of instruction where you stand in the front of the class and you conduct your lesson by speaking to the class. They listen to you, and then generally they complete an exercise afterwards, whether it's from the board or from a textbook or wherever. So direct instruction is the more common form of instruction that we encounter. The second one that we can look at as well is problem-based learning. Now, problem-based learning is a form of teaching style where students are challenged to gain knowledge via completing a problem exercise. So you as a teacher set out content where you are actually asking students questions and exercises, and you are prompting them on, giving them hints and allowing them to create knowledge for themselves. And then the last one, cooperative learning, is, as the name states, the students are working together, which we will not cover in today's lecture, but in your next lecture. But it's just there so that we know the 3 main teaching strategies for theory that we will be covering are as follows, and as that you can see on the screen. Okay, direct instruction. So direct instruction, as I said before, is a more uh, frequent form of instruction that you will encounter as a teacher. And this form of instruction is basically very structured, and it allows for mediated guidance on your part to students. So as you know, if you are speaking to a class at the front of the class and you're talking, your lesson is therefore structured. You have a plan of how things are going to be, in what order they are going to be said. So you build up knowledge until you achieve the objectives for that lesson, and you mediate learners as you're going along, asking them questions as to whether they understand content or not. Okay. And this also leads to as well connecting of their existing knowledge and new knowledge. So as a teacher, you have your your lesson plan, and you have set out in order what content should be learned. Coming back to my previous example where I told you that you cannot speak about uh, memory space and RAM without first knowing how a computer parts are connected together. So your knowledge of, or forming the connection between existing and new knowledge, is important, especially with direct instruction where students are receiving the information from you and they are not exploring or on their own and discovering things. Okay. Another important aspect of direct instruction is providing scaffolds for students. So when we speak about scaffolds, this basically entails you as a teacher teaching content in a manner where students can see what the next logical step is going to be in the learning process. So, if you are talking about graphics cards and memories and the amount of RAM required to display at a particular resolution, students have understood the graphics card RAM issue, they have understood the resolution of your monitor, and they can put together how much of RAM will be required for a particular resolution. This would be a form of scaffolding, or prompting users to discover the next step within the instruction. Okay. And one other important aspect that you as a teacher should actually look at as well is when you are giving direct instruction, make sure that you give small sections of new material and do not overload information for students in terms of new material. Okay. And lastly, Uh, direct instruction is the most common form in terms of the teaching process. However, there is nothing stopping you as a teacher from mixing it up and adopting some inquiry-based form of instruction. So engaging with students, asking them questions, or telling them to quickly research something on the internet and provide an answer. There isn't anything stopping you from adopting the method that works best for you, given the time constraints or the difficulty of the subject as well. So in essence, it is up to you to understand your the level of engagement within your students and adapt your teaching process towards this, towards learning or towards learners understanding. You could also go ahead and include aspects within your direct instruction, such as exploratory, incorporating an exploration phase. So you would be giving direct instruction, and like I said before, you ask them to quickly research something on their own computer. Give them 5 minutes to research, come back. This exploration allows them to actually form new knowledge on their own. Okay, so that's pretty much for direct instruction. The next form of instruction that we can speak about is your problem-based learning. So problem-based learning is, as the author in the first quotation speaks about, Polya. So Polya, according to your textbook, was known as the father of problem solving. And he states that learners need to find pleasure in the learning activity, be interested in the learning material, to discover as much of the learning content themselves. So this form of instruction relies a lot on students discovering, or learners discovering, knowledge for themselves by solving problems. And this is beneficial because once they discover things on their own, they are more likely to actually remember content. Okay, if you as a teacher were to actually set about using problem-based learning in your class, you should always follow a few general rules for this type of learning. The aim, as you can see in the second point over there, the aim of problem solving should be explicitly stated, coupled clear instruction and strategies to be used. So what are we speaking about? We're saying if you are employing problem-based learning in your classroom, you should always state clearly what the instruction for solving this problem is and what are the strategies that should be used. Okay. And furthermore, once that is stated, learners need to understand how they will be assessed whilst solving the problem and not just go off on a tangent and go about the wrong way of doing things. So it is important to know, using these few simple rules, about 3 or 4 guidelines. This will, mitigate a few issues that you encounter in problem-based learning where students may go off on a tangent and they may not necessarily know when to stop the exploration phase of their learning. So they're going about their research. At what point do they say, well, okay, I've achieved the goals for this lesson? And lastly, problem-based learning, if you are going about setting problems for the students to solve, it should be meaningful and relevant. Okay, this is important. And a few guidelines they specify in your book as well. These problems should relate to the real world. This will encourage them to or motivate them to solve the problem. It will also require decision making or judgments within the problem solving process. You know, it could be a multi-stage process that you have taught them how to solve problems with. It could be a group project, it could be an individual problem. It really is up to you. And also one of the things they speak about is to incorporate higher order thinking as well. So if you as a teacher want to incorporate this within your classroom, problem-based learning, just keep in mind these few simple rules when doing this, whether it's for individual or group exercises. Okay, so one example that is given to you, this is from your textbook as well. They speak about creating a diagram for a network. And the understanding behind this exercise or example is to make students get a better understanding of network devices and network communication devices within their theoretical aspects of their network curriculum. So we look at the question that's posed there, or the example, design a diagram for local business that has wants a local area network between 2 buildings for not more than 120 meters apart. And the following requirements should be addressed. There are 3 to 4 users in the 2 buildings. Uh, we're speaking about the communication medium, things like what wiring and so on and so forth, the connecting devices, and transmission methods and topology. So as an IT teacher, you will know your networking curriculum covers these topics. However, they don't specifically or necessarily cover it in the manner that you see on this slide. So you as a teacher, you could have given out the theoretical work or told them to research or do reading in their own time, and or explained it in front of the class too if you had the time, and then gone about giving them this example to further enforce their knowledge. So the question then states, motivate your decisions regarding devices, topology, cabling, and so on, and basically submit a report on this exercise. And then the example answer that they give, as you can see on your screen, the author talks about types of cables that will be used, your twisted pair cabling, which is your most common, or wireless, depending on the budget. Connecting devices, we will be using a router and an Ethernet-based router as well. Uh, Low-cost twisted pair, copper cabling, UTP, and so on and so forth. These are actually aspects or concepts within your networking curriculum, and the choices that are chosen here are based off the criteria or the allowances or the allowances that these technology affords one to create a network for. So if your students are writing these out, they should understand why they chose a router, 1000 base T, or UTP, and so on and so forth, or why they chose a bus or star topology. What are the differences? So as you can see over there, they need to motivate with the accordance with the design why they chose a particular setup or configuration, and so on and so forth. and they need to actually specify why the router was chosen, speak about standards and so on and so forth that you can see on the screen. And furthermore, they give you examples of the diagrams. So the first one you see there is your prototype, where they have two cloud setups and it's joined by a router. And then obviously the next step is to create a more detailed design of the network, where we have a router, and that's connecting two different LANs. We have a server on one side and on the other side, and then each subnet is connected, uh, or gives linkage for all the devices on that. Okay, so this is an example of how you would actually incorporate problem-based learning in your classroom. And this is a very effective way of teaching theory without making it boring. So remember, we spoke about earlier as well, and I told you guys, boredom in a classroom is a relevant or real issue. And incorporating exercises like this, or teaching strategies where you use problem-based learning, is an effective way of overcoming this. Okay, so this is as much as we are going to speak about for today's talk. In your next lecture, which is the following week, I will be talking about cooperative learning and also some of the pitfalls of theoretical learning as well. If you have any questions, you can email me at the following address. For next week, I will be putting up a Moodle activity for you guys. So please complete that tonight. Thank you.